Hi everybody. I just wanted to give you a brief rundown on how I approach the longer implication chart for the minimization of state machines. So what I've done is I've taken the liberty of doing a state machine that numbers its symbols from A through I, and I thought we could do something where I show this sort of hunting method that I use, which hunts for the most promising results first. We go for the so-called long hanging fruit. So it says A through I start at B and go through I with my implication chart. B, C, D, E, F, G, H, and finally I. So I'm going from the second letter to the last letter. And then I start horizontally going from the first letter to the penultimate letter. That's A through H. That's on the bottom. A, B, C, D, E, F, G, and H. So we stop one short of I. And then we proceed to do a lower triangular matrix. And now, first thing you want to do, and this is a little bit different from what others do, is you see what you can eliminate. So, for example, A is different from C, E, F, and H because the outputs are different. So, C, E, F, and H. C, E, F, and H. B is different from C, E, F, and H. And we'll just do all the ones first. G is different from H. And now we'll do the zeros. C is different from D, G, and I. So I got D, G, and I. This is supposed to be an I. Moreover, I've got E is different from G and I. And F is different from G and I. And H is different from I. And so now we've gotten rid of a whole bunch of stuff. I put an accidental mark here under the GD intersection. So what we can do, just to make that mark good and do something with it, let's take G and D and take a look. It's H and H, so that's good. And it says A and B. So we look up A and B. I don't know anything about it, so let's look at that. That's C and E. And it's E and E, so E and E, that sounds pretty good. What's C and E? So I look up C and E. I don't know anything about it, so C and E, that's I and I, that looks pretty good. F and H. Let's now look up F and H. I don't know anything about it, so F and H is C and E. Whoa. F and H is C and E, and it's also D and G. Now let's look at D and G. D and G, that's where we started. So now we've got something very interesting here, right? A and B depends on C and E. C and E depends on F and H. F and H depends on C and E, D and G. So between all of these things, we have a sort of a recursive looking loop. So that's sort of an interesting idea. Let's keep going. What about A and D? Let's see, A and D depends on E and H. A and D also depends on A and E. But A and E, we know, goes out. So that's okay. What about AG? So we take a look at AG. We have EH. A and G also depends on BE. But BE's got an X. So AG goes out. Let's take a look at that EH. E and H. That's C and I. And it's also F and D. C and I, that has an X in it. So that's pretty good. What about A and I? Let's look at A and I. So that's EF. And it's, that's an E. A and I is also BE. When I look up BE, I see there's an X in it, so this gets an X right away. So let's look up another one. How about this one? BG. B and G. Well, B and G is CH. And it's also, let's see now, BE. Well, BE's got an X in it. Let's go to look at that CH. C and H is C and I. But C and I's got an X in it, so that gets an X. So now let's look at that BI. Or actually, we go all the way up here, BD. BD is CH. CH has got an X in it, so that goes out right away. How about BI? BI is CF. I don't know much about CF. Let's look up CF. CF is EI. EI has an X. Since BI has CF in it, that gets an X. Let's try DE. DE is HI. HI has an X, so that gets an X. DF. DF has HE. HE has an X, so this gets an X. How about DH? H is CH. And CH has an X, so this gets an X. How about DI? DI is HF. And looks like HF depends on a couple of things. Let's see what else DI works with. So DI is HF, and it's also AB. But AB depends on CE. And CE depends on FH. And HF depends on CE and DG. And DG depends on ID. G. DG. GD depends on AB. Wow. So let's go and do some more. I have FE. So for, or EF if you like. I have EI. And I have GF. Looks like GF has got an X in it, so this gets an X in it. So we've got a few things that, oh, we haven't done one. GI. Let's look at GI. That's HF. HF has promise. And what else could it be dependent on? Let's see, GI is also B to B. So, very interesting. It looks like G is equal to or equivalent to I. F is equivalent to H. Okay. D is equivalent to G. Okay. C is equivalent to E. Okay. A is equivalent to B. And if D is equivalent to G, then I must be equivalent to D. And what else do we have? I think that's it. So now what we can do is we can say A is equivalent to B, therefore any reference to B can be replaced with A. So I can cross this out. And we can rewrite the whole thing if we like, but it's very good if we can just sort of say this will no longer be needed because we can now replace it with A. E is wiped out because that's going to be replaced with C. I is going to be wiped out and replaced with D. G will be wiped out and replaced with D. H will be wiped out and replaced with F. I don't know if you can quite see that there. Let's move this over just a little. So now you can kind of see that what we have done is we've gotten ourselves down to 1, 2, 3, 4 total states. And you can do the 4 states presumably with only 2 bits. And that's a good reduction. Thank you very much.